was the quantitative qualitative reasoning question. So this is kind of a question type that's very, what do I want to say, unique to the physics 1, physics 2 tests, in that basically what they want you to do is they want you to be able to reason in quantitative, that would be equations, graphs, that sort of thing, and qualitatively. Do you understand qualitatively how things are going to play out? Are you able to hear somebody explain stuff and say, that doesn't seem right based on what I know about physics? Okay, so for example here, okay, so we have I cropped out the kind of the middle of this question, so it doesn't really make sense, but specifically what I want to focus on is this question type here. So the part B1 says, okay, which aspects of the student's reasoning, if any, are correct? Okay, which aspects of the student's reasoning, if any, are incorrect? So this is a very common type. They don't have this on every test. Sometimes the quantitative qualitative takes a different way of looking at things, but it's fairly common. Okay, so can you read through this paragraph and pick out things that are correct and incorrect? So not just to say, oh, the student is wrong, but to say, well, their student is correct in this, but I would disagree in this, right? Okay, so in this problem, basically you have a block that compresses a spring, and the block is released, and it travels down this path that has friction on it, and it says now it's compressed twice as far. Is it going to travel? So the student predicts that it'll travel 6 times as far. Okay, and so you have to look at, okay, what about their reasoning is correct, and which aspects are incorrect. Okay, so the student reasons that since the spring will be compressed twice as much as before, the block will have more energy when it leaves the spring, so it will slide farther along the track before stopping at position 6D. Okay, so you would say, okay, the student is correct in that compressing it further would give it more energy, and therefore it's going to travel further. Okay, but you'd say that maybe they're incorrect in that, twice the distance doesn't correspond to 6 times the energy, because we would be reasoning that, right, this is based on elastic potential energy, and therefore it's going to scale as, basically x squared, so 2d. So if we went twice the distance, we would get 4 times the energy, so it would considerably go 4 times as far, right? And then we see part C says use quantitative reasoning, okay, including equations as needed to develop an expression for the new final position of the block. So express your answer in terms of D. Okay, so part B, we used qualitative reasoning. Okay, I explained that, okay, they're correct in this, but they're incorrect in this, and that's just I don't have to justify myself with equations or graphs or anything like that. I just have to explain, use from the paragraph that they gave me. I have to cite evidence saying, okay, this is what I observed is correct and incorrect. Then for C, they want me to do it myself. Okay, how would I solve these equations? How would I derive an equation? Okay, so there's the quantitative and the qualitative, and then so we see in D, explain how any correct aspects of the student's reasoning from part B are expressed by your mathematical relationship in part C. Okay, so now we have to tie the quantitative to the qualitative, and demonstrate that I can cite from my equation how these things are related. Okay, explain how your relationships in part C correct any incorrect aspects of the student's reasoning identified in part B. Okay, so I just showed in my equation that I just derived that this is why the student was incorrect about the distance, and I can show that from this equation that I just derived. Okay, yeah, and then refer to the relationships you wrote in part C, not just the final answer you obtained by manipulating those relationships. Okay, so they're asking you to refer not just to your final equation, okay, but to the equations that you use to derive that equation, because the equations that you started with, right, are the ones that demonstrate the real relationships. The ones that you derived demonstrate that you can do algebra, but they might not necessarily demonstrate that you understand the physics involved. So you have to explain that you understand the physics involved, explain how that relates to the original prompt, and how that relates to the equations, because that shows that you really understand the physics. If you can go between the real world evidence that you observe and the equations that you see on paper, then you're really doing some physics. Okay. So that's all I had for kind of demonstrating the different question types and how we would go through and analyze these. At this point, if anybody has any questions, open it up to any questions you have about Physics 1 or the classes that we're offering, or anything related to that.